idea is that over the course of the next 45 minutes or so, I will give you an overview of the industry status for machine learning. I will look into machine learning adoption, how companies are effectively scaling enterprise and their machine learning efforts from a practical perspective, the role of machine learning tools, machine learning platforms, automated machine learning, and also provide this in the context of the educational activities, what we do at the universities, what we do in corporate learning, and why this is important for us, faculty and educators, when we need to develop the content for different courses and programs, both for executives and for more technical people. So first things first, objectives and challenges, again, from an educational perspective. And well, first of all, I hate this part of the presentation because it's about talking about me, but I believe it's relevant that you get a little bit a sense of what I am doing for Northeastern University and the courses I teach and the content I've developed for the university and for other executive programs. So I've been 2 years in a row teaching and designing machine learning courses for Northeastern University. This is content that goes into their Master in Enterprise Applied Intelligence and their Master in Data Analytics. The courses I teach are AI Systems and Technologies, Machine Learning and Analytics, which is fully experiential learning, project-based, and another course which is special topics, and again, this is applied machine learning, so really applications of machine learning in practice. On the other hand, I've been also doing corporate learning, participating in corporate executive programs that goes into MBA students or young executives, or sometimes not so young, people in corporations willing to learn more about onboarding enterprise machine learning. Okay, so a little bit about me. I was a nerd back in the 90s. My first personal computer was a Commodore 64, if you can believe that. 64 kilobytes of RAM only. That was all the memory we had at the time. I turned into business, so I've been a corporate executive for many years for big technology companies at the time, like BlackBerry and Nokia. Then I turned entrepreneur, and I'm still the shareholder of a small company. I started investing, getting into venture capital back in 2010. Since then, I've been involved actively both in venture capital and private equity. And as a consequence of that, I got into board directorships, and I'm currently a non-executive director at Arowana, which is a private equity firm and fund management firm. Lately, I really wanted to catch up with the industry in the sense of being competent myself. In other words, I needed to learn machine learning, and the best way I could find to really learn and keep up with the technology was teaching. And this is what Richard Feynman said, best way to learn anything is to teach it. And this is what I am doing. I'm actually teaching with the ultimate objective of learning myself and keep up with everything that is happening in the machine learning world. Okay, so about the courses, and I want to give you a little bit of context of what I am teaching, what I'm doing for the university. The first courses that I started delivering were purely experiential learning, machine learning, and we cover all the bases here. Essentially, what we want is the students to really understand machine learning, but at the same time, really develop the applicability skills for all the methods, the traditional methods, or the more industrial methods, if you will, for machine learning. And we also put them under real life pressure in the sense that they have to work on their capstone project over their course. And this is a real life problem that they need to solve and ultimately report back to the company that is sponsoring the project. So there is time pressure there. There is pressure to get objectives, to get practical applications or a proof of concept, if you will. And for that, what we are pushing the students to do is to use more industrial tools rather than go into programming and code everything in Python or R. We still use Python or R if it is required, but we really push them to come up with the results using Tableau, Power BI, BigML, and even using automated ML that I will speak a little bit more later. The other course that I'm teaching and I designed as well, this is very recent. I worked on this course and I fully finished it only last quarter last year. This is AI systems and technologies, and as a consequence of demand from students and actually from the market, we wanted to have a more machine learning engineering oriented course for the students to be more proficient in everything surrounding the machine learning component. As you know, out there is a huge gap in the corporate world in terms of how many models actually reach production, which means out of all the machine learning experiments that a company, a corporation is doing, there is only a fraction of those that actually get the light and get implemented in real life. And this is a very well-known problem in the industry. We are trying to make the students more efficient, particularly working on the deployment side and integration of the machine learning models. This is all about the engineering around machine learning. So in this course, we cover things like Spark, SQL, obviously, because data management is always there. We use high-level tools like Databricks in order to teach Spark, and also BigML on the prediction, serving, and the deployment part. Okay, so what are the objectives for us as educators at the general level, a more general level? Obviously, we need to improve the practical skills of the students, and for us, it's important for them to get them exposed to real-life cases and, whenever possible, company projects, and work as much as possible on a project-based environment, as well as provide this experiential learning that also students will prefer. That means effectively that we focus more on the applicability aspects, and the theory, the math, all the foundational concepts come a little bit after. So we still keep the rigor that we need for the course and for the contents, but we try to really follow this sequence of practical applicability and the why of things, and then focus later on the theory and eventually even get into the math as a consequence of that. The other aspect that is relevant here is that not only technical skills need to be developed, the students are expected to be much more than that. And things like communication or team collaboration, the ability to understand customer problems and interact with customers, those are extremely relevant these days. So we also work that part, and we make sure that as part of the course, they really develop those skills as well. The other objective that we set up for ourselves is to make sure that beyond the traditional, more theoretical machine learning concepts, all the engineering part is also covered, even if it is only at a high level in some of the courses. But it's important that all these engineering elements that surround machine learning are also considered, and the students are prepared to work on a more end-to-end approach to machine learning. In my experience, what I found is that, and this is part of the challenges we face as educators, there are two camps here: the pure data science camp, in which everything is about technicalities and technical skills, math, statistics, analytics, machine learning methods, algorithms, programming, you name it. On the other side of the spectrum, you have MBAs, business students, or corporate executives, people in the early stage of their professional life. For them, it's all about soft skills, finance, eventually collaboration, teamwork, leadership, and eventually you get in MBAs also to get content around digital transformation or data-driven decisions, and that's perfectly fine. But eventually there is still a gap in the middle between those two worlds. And this is sometimes you can find these courses in the internet, like the missing course in data science or the missing course in the MBA. And this is a reflection of the fact that we have this gap still in the market in a way. Things like machine learning engineering. what we call MLOps, which is a fancy word for DevOps applied to machine learning. Things like project-based machine learning, data engineering, data pipelines, and data architecture, the tools and infrastructure. Those elements are missing in the majority of the traditional courses that we have. And this is exactly where we want to focus in the future. For more business-oriented students, data-driven leadership, in which they learn more about project management, including data science, and the tools and infrastructure that will allow a corporate executive or a business person to really lead a project and oversee how the execution of a project happens when it relates to machine learning and data science. Okay, more about the challenges. Whenever we try to develop content for our students, there is a balance we need to keep here. And what is happening is that hands-on experience and sometimes practical application of machine learning gets relegated. And that goes in favor of more theoretical content, or if you will, traditional data science content. Programming, math, statistics, like we mentioned before. The opposite is also true. So don't get me wrong, there are also other courses in which, because we focus so much on applicability, we miss the opportunity to really come down and deep dive into theoretical foundational knowledge. So it is always for us as teachers, as educators, to make a trade-off there and balance a play. The other change I noticed, this is maybe a little bit US-centric, but you tell me if this is different elsewhere in the world. There is a power shift in the syllabus. The student has a lot of power these days in terms of deciding what they want to be taught. And what is happening is that we as teachers need to be flexible enough to sometimes incorporate in the syllabus things that even if we know that the students are not going to use in real life, when they get into a job, when they get into working in real projects with their companies, there are things that is very unlikely they will use, like certain advanced deep learning methods, like GANs or even transformers. So things like that are rarely used unless you are in a cool startup in Silicon Valley that is developing something 5 years ahead. Despite that, the students really want to know about that, because there is a lot of hype around those methods and they want to know about them. So one of the things we are doing is to try to incorporate at least a high level overview of deep learning methods and advanced deep learning concepts as part of the lab or as part of the assignments. So at least they get a sense of where things are going, while we still cover what we know as a fact are going to be the more useful skills when they get out there. The other challenge, and I believe this is common for everyone, is more and more the students are coming from very different backgrounds, very different levels of experience. So you really need to adapt the way you run and you deliver your courses to make sure that you comply with that. As I said before, the goal is to find the optimal balance between teaching concepts, theory, and hands-on best practices, which ultimately will make them successful in the real world. Okay, so this is the second part of the presentation, and I wanted to cover a little bit about the industry status, how machine learning is being adopted in the enterprise, and particularly machine learning platforms and AutoML, why they are useful, why this is something we have to consider, as well as tools for our students. For that, I'd like to start with this quote. I really like this quote from Jensen Huang. He's the CEO of NVIDIA. He said this 3 years ago, if I recall correctly, in a show in San Jose, in Silicon Valley. He said that software is eating the world, but artificial intelligence is going to eat software. And it sounds a little bit intriguing, but in all fairness, the venture capital industry, which I know well, has been moving by the mantra that software is eating the world, and what machine learning is doing is changing the paradigm or the way we make software. So he's very spot on in saying that artificial intelligence is going to eat software in a way. It's not that We are going to get rid of the more traditional way of doing software anytime soon, but eventually it's true that doing machine learning requires a different set of skills, a different approach to developing software. And we need to be mindful of that, particularly in educational contexts. For a review of the adoption of machine learning, and for that I will be using the bell curve that applies to all technologies, and a little bit of the evolution we see here in this logistic curve. So phase A1, genesis of machine learning. This is the realm of academics and researchers. From there, you move into the 80s. Back in the 80s, custom-built products, and eventually the realm of data scientists. We still refer to experts and people properly trained to build those systems. And from that phase onwards, the first commercial products started to appear nearly 15, 20 years ago. Products finished for companies, for other users to use, and then lately, once we got into cloud and cloud machine learning and different machine learning as a service, if you will, then a new audience came, which is developers and analysts. We are in the middle of that transition as we speak. There is still a lot of data scientists, more traditional, open source oriented in the corporations, but very quickly we are moving into the developer and analyst phase. So what is happening in this transition is that the industry is moving very quickly from the open source solutions, Python, R-based, full stack programming for machine learning, the traditional custom-built products and internal machine learning platforms. We are moving into a more buy versus build. So it starts to make little sense to reinvent the wheel when it comes to developing machine learning products. And it's easier and cheaper, and particularly faster, to use industry tools in order to develop quickly those machine learning models that you need in order to succeed in the market. So that is happening as we speak, and very quickly accelerating. So the new audiences for machine learning are developers, analysts, and actually anyone with the will to really put some time and effort on using those tools moving forward. Another way of looking at that, and this is a landscape, a very good landscape from the people at Berkeley that I love, because it comprises all the tools that we use for machine learning and deep learning. This is not all of them, but give you a sense of how many tools and how much fragmentation we have today in terms of choice and tools for machine learning. Many of those tools have some sort of a niche application, but eventually the ones in the red box up there in the slide, the all-in-ones, those are the machine learning platforms that will enable to go over the full life cycle of machine learning, from data wrangling to model development, training, evaluation, and finally deployment. So those examples up there, like Microsoft, Amazon SageMaker, H2O, Data Robot, BigML, those are the tools that, or the machine learning platforms that will cover the majority of the functionality and the features that you need in order to develop an end-to-end machine learning platform. And those are the ones that I also recommend to be used in courses and educational environments, because they will allow the student to very quickly understand the whole process of developing machine learning applications end-to-end. Now, what is happening in terms of scaling machine learning in the enterprise? And this slide here is from McKinsey. It's actually an old slide, but it reflects very well what is happening in the enterprises, in the companies, when they think about applying machine learning. You obviously start with use cases, sources of value, the hypothesis that your people, your business experts think is going to deliver either more revenue or reduce cost in the enterprise. For that, you look into data. This is the first thing. Try to find if the company has enough data, either internally or externally. And from there, you move into techniques, tools, and how to effectively build models out of the data for that particular problem you identified. The ML modeling, requires the tools, and this is where the tools and the machine learning platforms are playing a key role moving forward. In the old times, you could build your own internal machine learning tool by using open source tools, but that was a multi-year effort and with significant costs. There is also the problem of technical debt and glue code that you eventually will run to, and we know that that eventually could be a problem in the future. It could be just the costs of maintenance in the future could kill your sources of value and your use cases. So moving forward, what the companies are doing is they are rethinking from a business point of view if it makes sense really to work everything in-house or eventually buy or license a machine learning platform that will enable them to build the models and get as quickly as possible to market. And that's the next step in the process, the workflow, what in this slide is called workflow integration. And this is all about making sure that the machine learning models get deployed and securing that you extract value from them in real life. And there is a final point here, which is developing your organizational skills. And this is also very relevant. And this is also where we educators play a role. And it's also considered an AI asset, if you will, is the ability to deliver the expertise within management, business teams, and the technical teams to make sure that all this workflow works nicely and efficiently. Another way of looking at those scaling dimensions for machine learning. As I mentioned before, use cases. This is very important, and the more you have, the better for your company. You may fail in terms of developing one of those use cases. So someone may have an idea in marketing, other people in your organization may have other ideas, other hypotheses for HR, for human resources. And out of the 100 ideas that may have, maybe only a fraction of them will succeed. And this is the reality today. But still, you want to increase the volume and the number of use cases that you have across your organization. Then you need to move as quickly as possible into model creation, building models for those use cases. And this is where rapid prototyping plays a role in order to validate the idea or discard it entirely. So no more resources or expenditure happens on that particular idea if it is not worthy for the enterprise. And the final phase is getting those models into production, making sure they are deployed. There are the engineering elements in place to make them work in real life and with real data. Two technologies play a key role here. AutoML, automated machine learning, is key in order to develop rapid prototyping. You will use AutoML in order to immediately, very quickly, even with a sample data set, validate if a model is going to be accurate enough or if the performance of the model is going to be at the level required in order to deliver the value. And with that, you can move into the next phase with a machine learning platform. You can quickly deploy the model. You can monitor the model, evaluate the model, look for problems, model drift in the future, manage the models properly. So volume in terms of use cases and model generation, and then at the same time, the success measured by the number of models you put into production, you deploy in your organization. So how many machine learning models are too many models? And this is a table from IBM. You can see in different sectors the amount of models, typical amount of models. It depends, obviously, and each business is going to be different. But you can see here that, for instance, for retail, we are talking about maybe dozens of models. But for instance, for healthcare, the range, the amount of models you need to deal with is in the thousands. Same for financial services. They say hundreds in this table, but I challenge that. I would say that financial services by now should be well over thousands of models that you need to manage, you need to have in order to be competitive. And the other example I have here is from Facebook, and this is from 2017. So actually, it's a little bit outdated. You may need to multiply by X the figures that you see here. But Facebook, when they announced FB Learner, which is their machine learning internal tool, they said that they were having more than 1 million machine learning models trained at that time. Those models were delivering already 6 million predictions per second. And again, that was almost 4 years ago. And 1/4 of their engineering team was already using the tool. So that gives you a sense of how a company like Facebook is using machine learning, or was using machine learning at that time. Since then, what we have seen is that many other corporations have also implemented internal machine learning tools and platforms in order to scale their machine learning efforts. And by the way, when we refer to machine learning platforms, I wanted to show you what is the typical architecture you may expect from, or you need to expect from a machine learning platform. So things that are important to bear in mind, and things that you will look for in a machine learning platform. Very importantly, the front end, how your knowledge workers, your employees, your business leaders are going to interact with the platform, your engineers as well. So the front end is critical in terms of having the right visualizations to deal with data, to deal with models, model evaluation, etc. Have the dashboard, a web-based dashboard that can be used in different computing environments, so literally everyone can access the tool one way or another. Having all the necessary tools to integrate, deploy, manage the models, manage the data, things like CLI, the command line interface, or the libraries, or integration with other tools that you may be using already in your company. Having, like in the case of BigML, a prediction server that eventually will allow you to scale the number of predictions once you roll out your models. And despite this is the front end, the other key element here is the scalability of the platform, the ability to really leverage cloud infrastructure to scale your machine learning efforts. And with that comes also dealing with complexity. So you have more models, those models they will need to be tweaked, they will need to also incorporate other methods, so there will be complex machine learning workflows, and for that you need programmability. Elements that you will look in your machine learning platform, having a strong API that will allow you to really integrate with disparate tools and other applications you may already have, or your customers may already have. So a strong API that has everything built in for you to use and integrate and deploy your models. And the backend, and this is also one of the things that sometimes is forgotten by corporations. Machine learning is a different way of doing software. There is a different way of managing data in order to make those models work. And sometimes the companies don't realize how important it is to have the right cloud infrastructure, the backend infrastructure that will support your machine learning efforts, particularly when you get into volume and doing machine learning at scale. So you need to have this smart infrastructure that auto deploys and is auto scalable as well, so that it goes with your efforts and you don't need to worry about it. Essentially, it's hidden somewhere under the hood and everything is working. Okay, so platforms, and I promised you I was going to give you more information about what is happening in the industry. So let me give you some dates and key announcements. So May 2017, Amazon, Jeff Bezos was saying that AI, or machine learning particularly, is a horizontal layer across all business units in his organization. And that's absolutely right. I mean, if you are a global organization, as long as there is data, enough data of a business process, that will be a candidate for a machine learning application. So that was 2017. And then I've been tracking what others have been doing. This is a short list of the usual suspects of the big tech companies. Facebook announced a big learner back in 2016. Google open sourced TensorFlow back in 2017. Netflix 2018. Uber released publicly the announcement. Michelangelo, which is their code name for their internal machine learning platform, back in September 2017. Same for Twitter, even before that, 2015. Airbnb 2018, LinkedIn 2018. So you see these are the public announcements. They have happened roughly 5-6 years ago for all these big companies. That means that they started their efforts way before that. At some point in time, there was a management decision to make public that they were implementing a machine learning internal tool in order to develop their AI strategy, which is, as you can imagine, something that particular announcement was addressed to their shareholders. They wanted to make sure, their CEOs wanted to make sure that their shareholder base understood that there is a clear AI strategy in the company for the future, and the reflection of that is that they were having an internal machine learning platform to scale the number of models and the benefits of deploying machine learning at scale. But not only these people, there are other companies as well that have jumped into that wagon after the usual suspects. And there is definitely an intention on doing this and publicly announcing it. You want to make sure that you get what is called an unfair platform advantage. You announce that you have been working for several years on having your internal machine learning platform to make sure that you are prepared for the future and that you can be more competitive than the other guy and the other competitors in your market. Other companies that did this: eBay in 2019, Lyft more recently, last year, AT&T, you know, the carrier in US, did that in 2017 as well. So no longer a traditional tech company, if you will, from Silicon Valley, but a more, telecom oriented organization has done that as well. Spotify 2019, Delta Airlines, and this one is not developed in-house. It's not open source based. They license the technology from a third party. That was also last year. General Electric, KT Telecom, and the list goes on and goes on and goes on. There is actually many more companies that are jumping into the strategy of scaling machine learning by applying, by buying or licensing third-party machine learning platforms. So what is going on here is that, well, we have a changing world we need to face. Customers, products, services that we offer as companies, and eventually the environment can be somehow stable, like you can see here, slide on the left hand side, or it can be always changing. And it can be very real-time oriented, like the case of Uber or Facebook or Google or many other companies like that. So you need to put the right platform in place to handle the specifics around machine learning applications, considering how the environment is going to change, how much information you need to process in real time, sometimes even latency is one of the issues you need to deal with. So those kind of things are really relevant depending on your use case and how your company operates. But definitely there is a tool or a platform that will help you or assist you in your efforts as a corporation. So jumping into a more practical approach here, this is the vendor landscape for machine learning as a service. Actually, what you have on the left-hand side is cloud services or companies that offer machine learning in the cloud. On the right-hand side, what you have is hybrid or on-premise implementations. But the players are mostly the same. There are two camps here. The traditional vendors, the likes of Microsoft or IBM or SAP or Amazon, and the challengers of the space, the companies that are actually pushing the envelope in terms of features and capabilities, companies like H2O, DataRobot, BigML, or Dataiku, really strong companies that now all of them are poised to become eventually public in the next few years. So no longer small players, they are now significant players. And definitely one of the options when you are considering a machine learning platform for your company. So a little bit about AutoML now. I wanted to cover that part as well and give you a flavor of what we have out there and how we can use it for the benefit of our students as well. So as you know, this is the old adage, all models are wrong, but some are useful. And this is what AutoML is primarily about, making sure that automatically all the algorithms you have available are run on your data set to produce models as quickly as possible, and then even select automatically the best algorithms and the best models for a specific data set and a problem. So a high-level definition for all AutoML, for automated machine learning, is automating feature generation and feature selection and model selection. So you either automate all of it or parts of it as part of your AutoML solution. Things that you may want to consider when we try to automate feature generations, for instance, methods like clustering, anomaly detection, association discovery, PCA, principal component analysis, if you need to run dimensionality reduction, and other methods that eventually will help you augment your data set and make sure that you get the right features in place for your model. There are different methods also to select the variables and the features that you want for your model. Recursive feature elimination is a popular one. There are many others, and you can script specifically those as well. And finally, you need to do model selection. And within model selection, there is an important caveat here, and particularly when you need to use neural networks, when you are chasing accuracy in your models. Really getting the right parameters and structure for your neural network is difficult. It takes a lot of energy and time. Not only that, you need to run the heuristics around your specific selection of parameters and then come back in a process that takes a lot of time. So in my mind, this is the biggest strength of AutoML. The possibility that you can get and find an optimal or a good structure for the parameters of your neural networks almost automatically or automatically. That's absolutely amazing and one of the, I believe, great things and progress that AutoML is bringing to the table. I'll speak about that a little bit more in the next slides. So what is happening here is that you look at the traditional cycle for building machine learning models. We go from problem formulation to all the way to predictions and measuring results. What is happening here is that you typically spend 80% of your time and effort and budget in data acquisition, data transformation, getting your data ready for your model. There is a high chance that you can automate a great deal of that effort using AutoML. So out of that 80%, there may be 50% that you can automate or semi-automate to reduce the burden of working on data preparation. So that's very important. The goal definition still remains completely human-driven. And I don't see that changing in the near future. There may be some things in the future, some early approaches later on down the road some years from now, but the goal definition so far is human domain. And then when we have our data ready for modeling, the model selection, algorithm selection, and the evaluation, all of that, which is typically 5% in a typical machine learning project, that can be fully automated, as well as measuring and monitoring the model. How the model behaves and performs, all of that can be absolutely automated using AutoML. So the benefits for a corporation are that you enable your knowledge workers, your analysts, your business leaders, even management to build stable and good models, and very quickly, by the way. You run your AutoML tool, eventually outcomes will be produced, resources will be produced, your models will be there, and you can start working immediately with them to discard if the idea is working or not, validate your hypothesis, etc. You can scale the number of predictive use cases. Remember that I was insisting very much, this is one of the main objectives in any enterprise that wants to remain competitive and be competitive in the future. Scale the number of use cases and problems that you can solve using machine learning. So this is a tool perfect for that. And the other key element that I find important when you use AutoML is the ability to explain the predictions and interpret your model. That's also paramount. And that's tricky because sometimes all the times you find this trade-off in which you need to shoot for accuracy. And for that, you may want to select methods like neural networks or deep learning, but eventually you lose interpretability because of that. So what we have with this tool is the ability to have all those models and eventually pick and choose the right models depending on what are our requirements from an interpretability perspective. I'm not going to enter into all the details in this slide, but I wanted to give it to you, and also we will be posting all materials. But I wanted to comment very quickly on some aspects that I believe are important when comparing different AutoML tools. Here we have Data Robot, H2O, and BigML AutoML solutions. Short description of them. As you see here is the features that you will look into an AutoML solution are the ability to prepare data, to get the data ready for model building, the optimization techniques. You want to look at what optimization techniques the AutoML solution is providing, the number and the different algorithms the AutoML solution is using. Speed may be relevant sometimes. I don't think it's that relevant, but it could be relevant, specifically if you are working with real-time applications. So if you need to develop a model in hours, because you need to have something very personalized for your users online, for instance, then eventually the speed could be one of the issues, speed or latency later on when you deploy the model. The model visualizations, interpretability, as we discussed before, the evaluations of the model, how they are done, and how much flexibility you have on that, and the ability to program everything, to script the work, and eventually manage complex workflows as well as deploying them. And I wanted to give you or bring your attention on one specific thing. There is meta learning, and this is becoming, I'm hearing a lot of researchers doing or developing AutoML talking about this, using meta learning or learning to learn in order to improve our ability to find the right model for a specific problem. So I wanted to spend a couple of minutes with that. So, and I will be covering particularly the way that BigML has implemented this AutoML solution and the way they implemented machine learning, meta learning for neural networks, for deep learning. So what they did in this case is to train roughly 300,000 deep neural networks on 50 data sets. With that, what you get is an optimum network structure for those neural networks for that given data set, with a given data set structure. Those are the number of fields, the types of those fields, some characteristics around those features, etc., that you use in order to train a machine learning model, so that this new machine learning model that has seen all those data, all those parameter structures on those 50 datasets on 300,000 deep neural networks is now trained on that, so that it can predict the optimum network structure for any new given dataset. For me, this is awesome. This is amazing, because suddenly you have all the knowledge about what is the parameter, the right parameter structure for a neural network, learned from more than 300,000 neural networks that already work on datasets, and you can benefit from that knowledge immediately to predict what could be the best approach for your particular problem now. So that is a time-saving component that you may want to look moving forward, particularly if you want to use AutoML. Not only that, sometimes the predicting network structure may be not the ideal one, but eventually it could be the seed for you to search the space of different parameter structures that could solve your problem. So you are really saving a lot of time with this one. A little bit about the future, very quickly. So the gray area you see here, all about statistical methods, probabilistic methods, and machine learning, supervised and supervised reinforcement learning. This is mostly where the industry is at today. And when I say industry, I mean we have the tools, we have mature models, proper implementations, well documented, that we can use in order to solve problems in real life. So we have neural networks, we have computer vision, we have natural language processing. It could be still a little bit difficult or fussy sometimes, but We have that. Now, what is the future going to bring us? And this is more about other methods, more on the symbolic area or sub-symbolic space, things like knowledge representation or planning, for which we have already reinforcement learning and agents, but there is still no proper reinforcement learning and agent platform that we can implement in a company unless you are really an expert on it. The next thing that I'm really excited about, and I believe is going to be a major breakthrough in the next 5 to 10 years, is reasoning. And it seems to be the research community is also agreeing that this is the right direction to go in the years to come. There is a lot of debate around not having proper causality implementations or representations in our machine learning models. So I guess that probably this is one of the areas we may want to improve in the future. And finally, search and optimization. So things like genetic algorithms, making use of those. Not that we can't today, but eventually they are relegated to very niche applications as we speak. So that's a little bit about the future, how that future translates into an actual machine learning platform. I'm taking again the example of BigML here. This is the progression of features and functionality in BigML machine learning platforms since 2011, when they started pioneering the API cloud machine learning service, all the way to 2017, when deep neural networks functionality was launched, and then AutoML, OptiML back in 2018 and 19. So you may expect your machine learning platform to stack up all this functionality, all these methods, algorithms, and new techniques as time goes by, as the methods mature and are more demanded in the marketplace. And in the future, what you will see that on top of that, we will get reasoning, knowledge representation, planning, and optimization. So that will be the future. And this will be the future also, particularly for BigML as well. So the next decade is going to be thrilling, at least. All right, so I'm almost done. Some recommendations based on what we saw during this presentation. So the world is changing very fast. Companies are adopting machine learning quickly, and they need to even speed up that process. So now we are moving quickly from build versus buy into buy versus build. Less open source, or only using open source for specific customizations that need to happen. But actually, you really want to come to market quickly, and if time to market is important, then you probably want to select one of the products that is available in the marketplace and immediately teach your people how to use it in order to deliver machine learning applications quickly. So machine learning tools and platforms are spreading. The success is measured by your ability to deploy models rapidly and efficiently. So this is very important also for new students or young executives, people in business as well, that will be leading those efforts in their respective companies. Technical depth is important in machine learning. We learned that. There is a lot of noise around ML ops and engineering. So this is also something we need to bear in mind, given that time to model deployment is almost equal to time to market. Our students and our executives need to be trained on that as well. And it doesn't matter if they are technical or business students or business executives, they will be confronting a world where they will be expected to understand and master machine learning and AI end-to-end. If maybe not experts in something specific like deep learning, they may need to be able to oversee a deep learning project, for instance. Okay. So more recommendations. So clearly MBAs and business leaders need to get and embrace machine learning and technicalities and technical understanding. There is no escape to that any longer. So that needs to be even included. And this is an advice for faculties and educators as well. We need to include machine learning in the curriculum for MBAs and for business students. It's important that we provide this industry approach, a more practical approach. Key concepts and the high-level modeling is mandatory. Still no hard coding. There no need to get into programming. Even eventually, some of your students may want to go there, but no need to do that. It's just provide this box-level, high-level understanding of how blocks work and how the things need to work in order to be successful there. Experiential learning is very important, hands-on on projects, proper use cases, well documented, understand the business value, why you are doing certain efforts, why you use certain algorithms, and what is the business value that underlying behind. And on the other hand, we also need to teach our technical students more soft skills. This is something missing as well. How to work in teams, how to divide a problem so you can succeed developing or deploying a machine learning application. Project management is also important. So all those kind of things need to be developed. And with that, I'll like to end with a quote that I love from Jack Welch. Jack Welch was the CEO of General Electric for many years. And he said this back in the 90s, when the rate of the change on the outside exceeds the rate of the change in the inside, the end is near. So when you see all of these things happening very quickly in the marketplace, how companies are embracing machine learning, you really realize the amount of change that is coming to us is amazing. So just bear that in mind.